Hey, what's up, guys? Chung here. And so this time, let's talk about another uh, recursion problem here. Problem called longest uni-value path, right? Number 687. It's marked as like as easy. I think, yeah, I think I would call it easy or like between easy and medium. No. So you're given a binary tree, right? And then you need to find the longest path whose uh, whose node are have they're all having the same value, right? This path may or may not pass through the node. So you're given like a tree here, right? So in this case, the node, the same, that's the longest path with whose node are the same, right? The uni value. Basically, there are two here, right? So the path will be the edges, right, for those nodes. And in this case, right? So what's this longest path here? It's the 1 and 2, right? So this is also 2. So for example, if there's another one here, like 5, right? 5, 5, 4, right? 1 and 1. So what's the longest path in this tree here? Starting from here, 1, 2, 3. So it's going to be 3, right? So I think it's going to be a classic like recursion problem, right? So what do? We're starting from the root here, right? And we keep calling this recursion method to the left tree and the right tree. Basically, we'll be returning we're trying to get the left path for this number, right? And then the right path for the same number. And then in the end, we just do a sum for those sides. And then in the end, we return, right? Since we're calling the same function for itself, right? We just need to return this number, return the max between the left and right. Because why? Because we can only go to one side, right? Let's say for example here, we can either go this side, right, or go to this side. That's the longest path for on the left side because so we have to choose either left or right, which will give us which give us a bigger number. Then that will be the current node's longest path, right? For its parent node. So let's try to code this, right? Uh, okay, let's see. We're gonna use this same thing here. So what do? We have a answer here. Oh, since we're going to have like a global variables here to store the final answers, let's create um, let's create a helper function, or I'll just create a class level variable here. Uh, init. I'll just create that. So self, right? Answer here, right? Equals 0. That will be our answer here. Mm, so yeah, as usual, we do a sanity check here. If not root, right? If not root, then we simply return 0, right? Else what? Else we do left, right? We do a left equals to the uh we we're trying to get the left sub path, right? Self dot longest value, right? So we're calling it self over and over, left, right? And then we'll do a right, same thing, right? Right, self longest univalue path. So, so how are we going to increase the value here, right? So what do? We check the left if the left side has the value on the left side node is equal to the current node. If it's the same, then we know, okay, so we have a value from the left side, and since the left side node is the same as the current node, then we know, okay, we can inherit, basically we can inherit this left side path and increase it by one, right? Basically, if root dot left, first we have to check if it has a left node, and what, and root dot left dot value equals to what, equals to the current value, right? If it's equal, then we know we can inherit this left value and set it to uh, increase by one. Same for the right side, right? If root dot right is not none and root dot right dot equals to root dot value. Same thing for the right side, increase by one, right? And now we have the both the left and the right. Then every time we have after we got the left side and the right side, we simply update our final result to check if the current left and right will give us a bigger path, right? And left plus right, right? Because since this path could go through the root, right? So we need to consider both left and right. Yeah. But notice here, when we return, right? When we return, we cannot return left plus right, right? Because let's say for example here, let's say I think we already discussed this, so I'm gonna give it like a better, hopefully a better explanation if I didn't explain it clear in before. 2, 3, 1, right? Let's say the current root is 4, right? Let's say the current root is 4, and let's say assuming let's say the left equals to 2 and the right equals to 1, right? So here we know we will be using 2 and 1 together, but when we return the value for this longest unit path, right? We don't return 2 plus 1. We can only return uh, the max, a max between this left and right, right? Keep that in mind. Why? Because let's say when this 4 return to 5, right? Let's say when this is finished, this recursion call will go back to 5, right? So when we do 5, we check the value returned from 4, right? So the biggest value from 5 to 4 is what? So we can basically, if from 5 we traverse, go to 4, and we can only pick one side, right? Basically, from 5, if we have trying to find a longest unit path for 5, we can only use either side of either left or right side of 4, right? We cannot use the same because when we draw a path for 5, you can only draw it from here. Uh, let me use a different color here. And we can uh we can only draw go the path can only go this side or this side, right? That's the two paths from 5 when we trying to calculate the 5. We, this is not the path, right? This is not the path because we cannot go back. So that's why we can only return one of the left and right. Okay, cool. So here we simply return uh, oh yeah, okay, sorry. So this problem here, uh, yeah, I think I shouldn't have used this like because here we need to return this answer, but meanwhile we also need to return this value for this recursion method. So but we cannot return two things at the same time. And although we can, right? I mean, but I think for this problem, I will just use like a in function, an a in method function here. So I'm gonna define a helper function here, or we can call it a DFS, whatever you prefer. And then yeah, so then I'm gonna define the answer here, right? Since we're doing a node here, yeah, I'll be updating root to node here. Okay, so and here is going to be answer, right? And then here, like I said, we just return the which one the bigger one among the left and the right, right? And then in the end, we just return the answer, but don't forget to call this DFS, right? With root. Yeah, I think pretty straightforward. I think that should do it. Yeah, colon. Oh, double equal sign here. Same thing here. I always forget about that. DFS. Oh, yeah, so many. I think I'm just tired, too tired today. Had a long meeting this afternoon, so my brain is not functioning well right now. Yeah. Uh, non-local answer here. What? Oh, yeah. Okay. Hopefully this is the last arrow. All right. What? Okay. Hmm. Let's see. Yeah, sorry guys. I think, yeah, like I said, it's bad. This is a bad video, bad explanation. But anyway, I'll try to finish this one. I think I made a mistake here. So basically, I shouldn't have done like in this way. I will, because I think one thing I missed here, after we get the values from the sub tree, uh, here I'm only checking if basically I'm only adding the to one if it's the same as this one, but I think I missed another one here. Else, right? Else I need to set it to back to 0. I think I just need to add a 0 here because um, I think this is kind of redundant, but I'll just leave it here because if we cannot inherit it, then we need to clear it, right? Because let's say the left side it's not same as this one, so for at least for this node, the left side doesn't have any path. That's why we need to uh, to reset it back to 0, right? Let's see. Yeah, cool. Yeah, I think this time passed. All right. Yeah, basically just recursively calling this left and right, right? But once we have the left and right, since we're trying to find the Univalue, so we need to compare the current root value with the left side. If it's the same, then we can inherit the length, the path from the left side. Otherwise, we need to set it back to 0. And then we every time we keep updating this final answer. And here, since this is a tree, and we need to return the path, the longest path for this current for this current for this current node, right? So that's going to be the either the left one or the right one. Which one is bigger? Cool. Okay, thank you for watching this not well explained video. And yeah, I'll do better next time. All right, anyway, see you guys. Bye.